If you want a 5 on AP Pre-Calculus, you're going to need to know how to analyze rational functions and determine their key features. So, first thing we should do is always factor our numerator and denominator, right? This will help us to determine the vertical asymptote, horizontal asymptote, and the holes of our graph, right? So x squared plus x minus 2 factors to x plus 2 and x minus 1. X minus 1. Great, okay. Now our denominator is going to factor to x minus 3 and x minus 1. Sorry, x minus 1. Okay. So both the numerator and the denominator have a factor of x minus 1, which means we can cross it out. Or should I say cancel it out, right? And our final equation for f of x will be x plus 2 over x minus 3. Now, see how we crossed out x minus 1? That means that x equals 1. We're going to have a hole in this graph, right? And remember, x cannot be 1 because if we plug in 1, the denominator is going to be 0, which will lead to the equation being undefined, right? So if we plug in x equals 1 into our final version of f of x, we are going to get f of 1 equals negative 3 over 2. Okay, perfect. So we have our x coordinate for the hole, and we have the y coordinate for a hole. So that means we can write the final coordinate, which is going to be 1, comma, negative 3 over 2. Okay, that's perfect. So now I can erase all of this. Perfect, okay. Now let's determine our vertical asymptote. Vertical asymptote is incredibly easy because we just find the value for x that's going to make our denominator 0 in the final equation for f of x, right? So we can set we can set x minus 3 equal to 0, and we get x is equal to 3. That means our vertical asymptote is x equals 3. See? Very simple. X equals 3. Okay, perfect. Now our horizontal asymptote will depend on the degree of the numerator and the denominator. So since the degree of the numerator and the denominator is the same, it's 2. We're looking at this equation for the horizontal asymptote. Since it is the same, it's going to be y is going to equal to the coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which is also 1. So the equation for our horizontal asymptote is just y is equal to 1. Very simple. Y equal to 1. Now, x-intercepts and y-intercepts are also easy. For our y-intercept, we just find the value, we just set x equal to 0 on our final equation. And we're going to get 2 over negative 3. So our y-intercept is going to be 0, comma, 2 over negative 3. X-intercept. Now, x-intercept is we use a little different process, right? We just set the numerator equal to 0, right? I'm going to get x is equal to negative 2. Yeah, and this is our x-intercept, right? It's negative 2, comma 0. Let me give you another example that you can pause your video, try it out, and then we're going to solve it together. And this example is very simple, right? The leading coefficients of both the numerator and the denominator is 1. So you guys should be able to get the hang of this. Now x squared plus x minus 2, this is a 2, over x squared minus 5x squared minus 5x plus 6. Okay, go ahead and pause your video, solve this, and I'll be right back with you. Okay, we're back. So let's start factoring our numerator and denominator. Now, x squared plus x minus 2 factors to x plus 2 times x minus 1. And our denominator of x squared minus 5x plus 6 factors to x minus 2 and x minus 3. X minus 2 and x minus 3. Okay, so now we see nothing can cancel out, right? So that means we're not going to have a single hole in this graph, but instead we're going to have two vertical asymptotes, right? Because two x values can make the denominator 0. And more specifically, x equals 2 can make the equation undefined by making the denominator 0, and x equals 3 can make the equation undefined. So these are two vertical asymptotes in this example, not one. X equals 2 and x equals 3. Okay, great. Now, the horizontal asymptote, I'm pretty sure it's the exact same as in our previous example, right? The degree of the leading coefficient of the numerator is 1, and then we divide that by the leading coefficient of the denominator, which is also 1. So our horizontal asymptote is y is equal to 1. Great. Okay. Now x-intercept, just like in the previous example, we set our numerator equal to 0, x plus 2 and x minus 1 equals 0. Okay, so using zero product property, we get x is equal to negative 2 and x is equal to 1. So again, we're going to have two x-intercepts. We're going to have negative 2 comma 0 and 1 comma 0. Okay, y-intercept, we're gonna plug in 0 for x. We get f of 0 equals to, so we're gonna have 0 squared plus 0 minus 2, and then we're gonna have 0 squared minus 5 times 0 plus 6. So we get negative 2 over 6, which is just equal to negative 1 over 3. Okay, great. So that's going to be our y-intercept, right? So we're going to get 0, common negative 1 over 3. Okay. So yeah, everything. Alright, in this video, we learned how to determine all the most important key features of rational graphs. This is the first video on my channel, so if you enjoyed my explanations, give this a like, and make sure to comment any other topics you guys would like me to go over. Maybe how to graph all of this, which is actually derived from all these key features. So yeah, check out my future videos, and hopefully I'll see you later. Bye bye.